Okay, this is the Unit 8 test review. So we are finding the LCD, the least common denominator, on number 1, 2, and 3. We are not solving. So on number 1, remember when you were finding the least common denominator, you always want to factor the denominators if you can. Well, x plus 3, there's no factors. But x squared minus 9 is a perfect square minus a perfect square. So this becomes x minus 3, x plus 3. Because it's also x squared minus 3 squared. Okay, so that follows the difference of squares formula. Okay, so knowing that, we have an x plus 3 here and here, but this one has an x minus 3 that one doesn't, so it needs the x minus 3. Therefore, my LCD is x minus 3, x plus 3. Okay, the next one, there's no plus or minus, so we just need to multiply by something. So I want to realize that we have 6 and 30. Well, 6 goes into 30 5 times, so I can multiply this by 5, and it'll become 30. Okay? Okay, this one has x cubed, and this one just has x, so I can multiply this one by x squared, because x squared times x is x cubed. This one has just y, this one has y squared, so I can multiply this one by another y, and it'll become y squared. So that would give me 30 x cubed y squared. This one would also give me 30 x cubed y squared. So that's my GCF. Now this one's a little more. So this is a perfect square minus a perfect square. This is 4 squared. So this can become x minus 4, x plus 4. Now this one we're going to have to do the snowflake. A is 1, B is negative 6, C is 8. 1 times 8 is 8, B is negative 6, AX, AX. So what multiplies to give me 8 but adds to give me negative 6? Well, the fact that the top number is positive and the bottom number is negative means I'm going to have a double negative. Okay, and 2 and 4 make 6 and multiply to 8. So this becomes x minus 2, x minus 4. Well, look, they both have an x minus 4, but this one doesn't have an x plus 4. And this one doesn't have an x minus 2. So my LCD is x minus 2, x minus 4, x plus 4. Okay, so it says simplify each expression, show all work. Okay, this is super important because to get credit on your test, you have to show all your work. So looking at this one, remember we're going to start by just taking out GCF. So 4 is my smaller number, and 4 does go into 12. So when I take that out, I get 3x minus 1 over, well, 5 goes into 15, so 5 is my GCF. 5 goes into 15 3 times, and there once. And then I can cancel. The 3x minus 1's cancel, and I get 4 over 5. Okay, on number 5, I want you to realize there's not a fraction on the top. And remember, with the top has to be a fraction, one fraction, and the bottom has to be a single fraction. So this right now is technically 2 fractions. This has a denominator of y, this has a denominator of 1. So I can multiply this one by y. Now they both have 1y or y. But if I multiply that by y, I have to multiply this by y. Well, y times y is y squared over y. Because now that they have a common denominator, we can put them together. Now remember, there's no equal signs here. Therefore, we cannot cancel denominators. Okay, so then this is division. So I have y minus 2 over 1 divided by, I'm going to factor that. I get y minus 2, y plus 2, because it's a perfect square minus a perfect square. But since it's division, we have to flip and multiply. So I get y, minus 2 multiplied by y over y minus 2, y plus 2. So the y minus 2's cancel. I'm left with just y on top. And 1 times y plus 2 is just y plus 2. Now remember, these y's don't cancel because anytime you have plus or minus, it has to be exactly the same. And this doesn't have a plus 2, therefore nothing can cancel. Let's look at number 6. It's already set up for multiplication, but we need to factor everything so we can see what cancels. So this is a perfect square minus a perfect square. So I get x minus 2, x plus 2. This is a perfect square minus a perfect square because this is 2x squared minus 1 squared. So I get 2x minus 1, 2x plus 1. No GCF can't factor. So I'm going to rewrite this. I get x minus 2, x plus 2 times 2x minus 1 over 2x minus 1, 2x plus 1, x plus 2. And we're going to cancel what we can cancel. So the 2x minus 1's cancel, the x plus 2's cancel, and we're left with x minus 2 over 2x plus 1. Okay, this denominator has no plus or minus, so we are looking for anything that those two numbers can be. Well, they both have a y, so we don't need to worry about letters. But 4 can't turn into 5, and 5 can't turn into 4 by multiplying. So we are going to, they can both become 20. So this one would be times 5. This one would be times 4. And now both denominators equal 20y. So we get 5 times 1, which is 5, plus 8 times 4, which is 32. Questioning my math skills today, y'all. Yes, okay. For some reason I felt like that was wrong. Okay, and then since they have a common denominator now and they're under 1, we can't actually combine them because there's no letters. They're like terms. So we get 37 over 20y. And that does not simplify. So there's your answer. So this one, I want you to be careful with subtraction. So I'm going to bring that subtraction symbol up so we don't forget about it. This can't factor, but this can. This becomes x minus 1, x plus 1. Okay, and so this is just x plus 1, so it needs the x minus 1. So I now have a common denominator of x minus 1, x plus 1, but I need to distribute. So 3 times x is 3x, 3 times negative 1 is negative 3, minus 2, combine like terms, which gives me 3x minus 5 over x minus 1, x plus 1. There's no GCF, so I cannot simplify, and there is my answer. Now this one we're going to have to factor and factor to see what they have in common and see what they don't. So I'm going to factor this one right here. I get a is 1, 1 times 2 is 2, b is 3. So what multiplies to give me 2 but adds to give me 3 is 2 and 1. So this becomes x plus 1, x plus 2. Now this one, I know I'm doing this kind of tiny. 2 times negative 3 is negative 6. B is negative 1. So this is 2x, 2x. So something's going to simplify. What multiplies to give me negative 6 but adds to give me negative 1? It's going to be negative 3 and positive 2. 2 over 3 does not simplify. But 2 over 2 does to 1. So this becomes x plus 1. So they have the x plus 1 in common. This one doesn't have the x plus 2. And this one doesn't have the 2x minus 3. So now that my denominators match, we can put it above the single denominator. x times 2x is 2x squared. X times negative 3 is negative 3x. 2x times x is positive 2x squared. 2x times 2 is positive 4x. So we end up with 4x squared plus 1x Okay, so now we have a GCF, but we can't do the snowflake because there's no C value. So I'm just going to take out an x, and I end up with x plus 1, and nothing cancels. So that is our answer. Alright, sorry, somebody was coming in. Okay, on these bottom three. So I want you to realize on this one that this is not an order. And order is super important because these look the same, but they really are not. So when I put it in order, I end up with this, which is not the same. So I can take that negative out, and I take a negative from both of them. Well, that positive will become negative. Okay, and now they are the same on the inside. So all I need to make them have a common denominator is give this one a negative. So I end up getting negative x plus 1 over negative x minus 1. Well, if I take that negative out up top, I get negative x minus 1 over negative x minus 1. Well, two negatives makes a positive, and anything divided by itself is positive 1. Here, this is a perfect square minus a perfect square. This is a GCF problem. So I'm going to take out the GCF. I get 2, and that leaves me with 2x minus 3. Well, this gives me 2x squared minus 3 squared. So 2x minus 3, 2x plus 3. So the 2x minus 3's cancel, and I get 2 over 2x plus 3. Okay, so here we have a fraction over a fraction. Remember, anytime we have that, we need to have a single fraction on top and a single fraction on bottom. So this is p, this is q. They cannot turn into each other, so we're going to multiply them. So this would be times q. This would be times p. So now that is 1q plus 1p over pq. That looks really confusing. Okay, and this is PQ, so this needs to be PQ, which just means times PQ. So I get 1PQ minus 1 over PQ. And now I'm going to kind of skip a step. I know that these are dividing, so if I flip it, I can multiply. So I get Q plus P over PQ times, flip it, so PQ over PQ minus 1. So the PQ's cancel, and I get Q plus P over PQ minus 1. Okay, so let's start looking at the back. Okay, so cool thing is number 13, they already have common denominator. So the only thing though, we had a lot of struggle on this on the assessment. When you have a negative in the middle, you have to distribute it. So I'm going to rewrite this as x plus 1 minus 2x plus 1, because two negatives makes a positive. So then I'm going to combine like terms. So x minus 2x is negative x. 1 plus 1 is 2 over x. And there's your answer. Okay, so let's look at number 14. There's no plus or minus on the bottom, so we're just multiplying. What can 4 and 6 both become? Well, times 2, this can become 12, and times 3, this can become 12. But this has an x squared, and this only has an x, so I can multiply this one by another x, and that will become, they'll both become 12x squared. So 3 times 4 is 12, x squared. 6 times 2 is 12, x times x is x squared. So now we have a common denominator. And again, we have that minus. So I'm going to distribute 3 times 2x is 6x. 3 times 1 is 3. Now I have to give this negative to that. So this becomes negative x, negative 3, and then 2x times negative x is negative 2x squared. 2x times negative 3 is negative 6x. So when I simplify, well, the 6x's cancel, and I'm going to put this in order, negative 2x squared plus 3 over 12x squared. Well, these are not perfect squares, so nothing here can simplify. Therefore, this is my answer. Okay, so let's look at 15. On number 15, we again do not have a common denominator yet, but 7 can turn into 14. They both already have an x, so just multiply this by 2. Well, 2 times 7x is 14x, and that's 14x, so now we have a common denominator. Bring that negative up so you don't forget about it. 2 times 12 is 24, minus 3. There's no denominators, variables up top. So this ends up with 21 over 14x. Well, that can simplify, so we definitely need to simplify it. 7 goes into 21 3 times, and 7 goes into 14 2 times. So our answer is 3 over 2x. Okay, these get kind of yucky. Okay, so on this one we need to realize it's division, which means we're going to flip something. And we need to do our factor, snowflake, goodness gracious. So this is 2x, 2x, 2 times negative 1 is negative 2, b is negative 1. So this is going to be a negative 2 and a positive 1. So 2x plus 1. And that's actually going to simplify to x over negative 1, so x minus 1. Now for that one, I have 2x, 2x, 2 times negative 2 is negative 4, b is negative 3, so it's going to be negative 4 and positive 1. So 2x plus 1 does not simplify, but this does to x over negative 2. And I want you to realize technically the top's factor as well. So I'm going to rewrite this first one. That's a perfect square minus a perfect square. I end up with x minus 1, x plus 1 over 2x plus 1, x minus 1. Now I'm going to flip, and I get 2x plus 1, x minus 2 over, this is a perfect square minus a perfect square, so we get x minus 2, x plus 2. So x minus 2's cancel, x not plus 1, dang it, I did that. That's still there, I'm going to rewrite it so I don't forget. The x minus 1's cancel, and the 2x plus 1's cancel. So I'm left with that x plus 1 over x plus 2. Lots of canceling, lots of factoring. So again, lots of factoring. I'm going to come down here and factor them. So this is for this first one. I get x, or 1x, 1x. 1 times negative 2 is negative 2. b is 1. So this can be a positive 2, negative 1. So that became x plus 2, x minus 1. So let's do that bottom one. I get x, 1 times 6 is 6. It's 5, so it's going to be 2 and 3. So this is x plus 2, x plus 3. Now this is already multiplication, so we're not flipping anything. And I'm going to keep on doing this. So that gives me 1x, 1x. 1 times 3 is 3. b is 4. 1 and 3 give me 4. So this is x plus 1, x plus 3. This one is A, so 1x, 1 times negative 4 is negative 4, B is positive 3, so I'm going to have negative 1, positive 4, so x minus 1, x plus 4. So now we can start canceling. So these x plus 2's cancel, x minus 1 cancels, x plus 3 cancels, and I'm left with x plus 1 over x plus 4. Now on your test, I'm not going to have one where you have to factor 4 times, but factoring's a good skill to practice right now. So last one. Well, not really. We have 6 more, but 5 more. But on this piece, this section. So first off, we have a GCF of 3. And then I'm left with x squared minus 25 over, here's a GCF of 6. And that leaves me with x minus 5. When I take that 6 out, I'm going to go ahead and change it to multiplication and flip. Okay. I'm also going to factor this. This becomes x minus 5, x plus 5. So now I have the x minus 5's that cancel, and that's it. So I have 3, x plus 5, x plus 1, over 6 times 24. Well, that will simplify, so we'll rewrite it in just a second. I'm going to leave it like this, because this breaks down to 2 times 3. So I end up with x plus 5, x plus 1, over 8x. Okay, so now let's get down to the equations. So now we do want to find common denominators, and we do want them to match. So we are going to start with this one. This is x plus 3, this is x minus 2. They do not match, so they cannot turn into each other. So this needs an x plus 3, and this needs an x minus 2. So 5 times x, because now that they match we can cancel, is 5x. 5 times negative 2 is negative 10, equals 4 times x is 4x, and 4 times 3 is 12. So I'm going to subtract 4x from both sides, because now I'm just solving, and I get x, so I'm going to add 10 to both sides, equals 22. Okay, and we could plug it in and check our work. So we should get 5 divided by, well, 22 plus 3 is 25. So that equals 0.2, and then 4 divided by 22 minus is 20. Whoa, is 0.2, so they're the same. I typed that weird, but it's the same thing. Okay, so let's keep going. On this one, again, same concept. This has an x plus 3. This one doesn't. So this one needs an x plus 3. This one has an x minus 5. This one doesn't, so this one needs an x minus 5. So I'm going to distribute. Now that they match, I can cancel them, and I get 5x minus 25 equals 3x plus 9. So I'm solving for x. I'm going to subtract 3x from both sides. I always move my smallest x first. I get 2x, and I'm going to add 25 to both sides. Equals 25, 34. I had to do that in my head, or on my fingers. Divide both sides by 2, and I get x equals 17. On number 24, we need to factor what we can factor. Well, the only one we can factor is this one in the middle. So I'm going to come over here, and I know a is 1. A times c is 12. B is 7. Well, 3 times 4 is 12, and 3 plus 4 is 7. So this gives me x plus 3, x plus 4. Well, the cool thing is x plus 4 is already there, but it needs the x plus 3. Over here has the x plus 3, but not the x plus 4. And now you'll see that all the denominators are x plus 3, x plus 4. So we can cancel the denominators because it's an equation. And I get x squared plus 3x plus 8x plus 28, because nothing here changed. It already had the LCD, and then equals 4x plus 16. So now we need to simplify. I do have a squared, so we need to get everything on one side and set it equal to 0. Okay, so I have x squared 8, 9, 10, 11 plus 11x plus 28 equals 4x plus 16. So minus 4x on both sides, minus 16 on both sides, and I get x squared plus 7x. Oh, that gives me 12. Okay, equals 0, and now we'll do factoring again. So a is 1. A times c is 12, because we have to solve this, and when you have something squared, you have to factor it. B is 7. So again, 3 and 4. It's the same as before. And so we get x plus 3, x plus 4. How weird is that? Equals 0. So when I set those both equal to 0 and solve, come over here, x plus 3 equals 0, minus 3, minus 3. X plus 4 equals 0, minus 4, minus 4. X equals negative 4. So I have x equals negative 3, x equals negative 4. Now, two things I forgot to do, or one thing I forgot to do on all of these, is to find what x cannot be, my domain. So, domain here, well, x can, if I put a positive 2 in there and a negative 3, those would be, so that one is fine, that's our solution. Here, a positive 5 and a negative 3. Remember, you're doing what would make the denominator equal 0. So I'm setting both factors in the denominator equal to 0. So a positive 5 minus 5 would give me 0, and a negative 3 plus 3 would give me 0. So that's why those are there. And then on this next one, I can't have a negative 3 or a positive of a negative 4. Well, that's what we got, so this one is actually no solution. It's hard to read, but it's there. So that one's no solution. I just got on a roll solving and forgot about, and it even tells you, do not forget to check the extraneous solution. So that means like your domains, and if it can be a solution. So this is no solution. Okay, let's look at number 26. Okay, so we need to factor this and this. This is a perfect square, so it's quick. This one I need to do the snowflake. So a times c is 1, b is negative 2. Well, when the top's positive and the bottom's negative, I'm going to have a double negative. And the only thing that multiplies to give you 1 is 1 and 1, which actually adds to give you negative 2. So this is x minus 1, x minus 1. So this has an x plus 1. This has 2 x minus 1s. This one only has 1 x minus 1. So this needs another x minus 1. This one needs an x plus 1. And this one needs both. No, it needs 2 x minus 1s. Goodness gracious, don't listen to me. It already has the plus 1. It needs the 2 x minus 1s. So once we give it the 2 x minus 1s, our denominators are all the same. let's go ahead and find our domain before we forget like I did. So a positive 1 would cancel a negative 1, and a negative 1 would cancel a positive 1. So it can't be negative 1 or positive 1. Okay, and now since it's an equation, I can cancel my denominators, and I get x times x is x squared, x times 1 is x, equals, let's factor this first. So x times x, I'm going to leave the 2. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. Negative 1 times 1 is positive 1. Plus 4 times x is 4x. 4 times negative 1 is negative 4. Child, you should have a mask on. Okay, so now we just need to distribute this, but I'm going to combine these first. So I get x squared plus x equals 2. This simplifies to x, squared, minus 2x plus 1. So that gives me 2x squared minus 4x plus 2 plus 4x minus 4. Because remember, I simplified that to that. And now we just need to combine like terms. Since we have something squared, we will have to factor, so we need to set this equal to 0. But I'm going to combine like terms first. So these actually cancel. And I get x squared plus x equals 2x squared.
I just want to send out a special good luck to our students taking the English 2 test today.
Okay, so where was I? This gives me negative 2. So I'm going to move these. So minus x squared minus x needs to go in the middle. And I get 0 equals 2x squared. 1x squared. Combining those. Minus x minus 2. So we need to factor that. A is 1. A times c is negative 2. B is negative 1. So a positive 2 and a negative 1 multiply to give me negative 2, but add, negative 2 and a positive 1. Add to give me negative 1. So this becomes x minus 2 equals 0, and x plus 1 equals 0. Add 2, x equals 2. Minus 1, x equals negative 1. Well, my domain says that x cannot be negative 1, so my only answer is x equals 2. Okay, last one for me. When I factor this, I'm going to come down here. I'm running out of space. I get x and x, negative 30 and 1. So that's going to be 6 and negative 5. So the nice thing is those are those. So this is our LCD. So let's go ahead and find our domain. X cannot equal negative 6 or positive 5. Remember, if you struggle with finding your domain, you're just setting those equal to 0 and solving. Well, this would be negative 6, and this would be positive 5. Okay, so that's why those are there. Okay, so this one needs the x minus 5. This one needs the x plus 6. And now that the denominators are all the same, we can cancel them because it's an equation. Okay, that's only these 5 problems. The other ones did not have equal signs, therefore you could not cancel. So 5x times x is 5x squared. 5x times 6 is 30x. Plus 4 times x is 4x. 4 times negative 5 is negative 20. Equals this. I'm going to combine like terms. Whoa, that's not, just kidding. These two are like terms, not that one. So that gives me 34x minus 20 equals this. Yeah, okay, sorry, I was second guessing myself. Okay, and so now I need to move these over because I have an x squared. So minus 54x minus 5. So I get 5x squared. That leaves me with 20x minus 25 equals 0. Well, before I can even factor this, I have a GCF, and I'm going to make my life easier and take that out. And I'm left with x squared plus 4x minus 5. So really, we're going to ignore that because when we solve, 5 cannot equal 0. So I'm going to do my factor. I get 1x. 1 times negative 5 is negative 5. b is 4. So this can be positive 5 and a negative 1. So x plus 5 equals 0. X minus 1 equals 0. Add 1 on both sides, and I get x equals 1. Subtract 5 on both sides, and I get x equals negative 5. Both of those can be solutions. So I get x equals 1. Can you please leave it alone? X equals negative 5 with my tiny bit of space left.